This is a review of some specific problems from your review for the second semester final. First one that we're going to do is number 2, and it involves properties of exponents. The first thing you want to do with number 2 is you see this exponent outside. You want to distribute that to each element within the parentheses. Okay, there's only one term. Clearly, there's no pluses or minuses, so that indicates one term. But I'm going to distribute that -1 to everything inside. Okay, when that happens, I got to make sure, and again, a lot of times students forget to distribute it to the 5. It has to be distributed to there as well. So when that happens, I get 5 to the -1, x to the -2 to the -1, which is x to the 2nd, and then y to the 5th to the -1, which is y to the -5th. So what I end up with there is 5 to the -1, x to the 2nd, and y to the -5. In order to make that proper, I want to make sure that I get my negative exponents here and here to the bottom of a fraction. So what that means, I'm going to make a top and bottom, make a numerator denominator. My x squared stays on top. That doesn't change. My 5 to the -1 goes to the bottom, and my y to the -5 goes to the bottom. When they go to the bottom, they become positive. All right, number 5. The next one doesn't really involve properties of exponents, maybe a little bit, but it's mostly just a different topic, which is double distribute, is what I call it. I'm not sure what your teacher calls it, but basically what I want to do is distribute each term. I'm going to distribute the x. So that gives me 6x squared times x, which is 6x to the 3rd, x times -5x, which is -5x squared, x times 2, which is 2x, and then I'm going to distribute the 4. So that's why I say double distribute. You can distribute both the x and the 4. So 4 times 6x squared is 24x squared. 4 times -5x is -20x. And then 4 times 2 is 8x. At this point, not 8x, just 8. At this point, I want to combine like terms. So 6x to the 3rd has no pairs, no other x to the 3rds, no other like terms. I'm just going to rewrite it. -5x squared can be combined with 24x squared, which will make 19x squared. 2x can be combined with -20 to make -18x, and then 8 has nothing else, so that would just be 8. So my total answer here is 6x to the 3rd plus 19x squared plus 18x plus 8. Moving on, f of x equals x3 minus x, and g of x equals 2x plus 5. And you want to do g of f of x. This is a composition of functions. So basically what you're going to do here is g of f of x is I'm going to take this function, I'm going to plug it in for x. Okay, a lot of times students get confused here. But just think of it like any function. If I wanted to take like g of 2, well, what would you do? Well, I'd take 2 and I'd replace x. Everywhere that I see x, I'd replace it with 2. So I get 2 times 2 plus 5. So that would actually be a number that would give me 9. Well, I'm not replacing x with a number in this problem. I'm replacing x with another function, which is 3 minus x. So composition of functions, this is what I want to do. So instead of saying g of f of x, I'm just going to write f of x is 3 minus x. So g of 3 minus x would be 2 times 3 minus x plus 5. So you see how I just replaced x here with 3 minus x. That's all I did. That's called the composition of functions. You distribute, so I get 6 minus 2x plus 5. Combine like terms, I get -2x plus 11. If you put it in the different order, like 11 minus 2x, that's fine as well. For the next one, I got g of f of 2. Well, it's a little bit different because I'm not plugging a function into g. I'm plugging f of 2 in. So off to the side, I'm going to evaluate f of 2. Well, f of x was 3 minus x. So f of 2 would be 3 minus 2, which is very simply just 1. So in this problem, this is no longer, to me, it's no longer g of f of 2, it's g of 1. Well, that's easy because g of x is 2x plus 5. G of 1 is 1 plus 5. And that's a function, input, output. You input a value, you output the other value. So my final answer for that one is 7. Okay, I shouldn't have boxed the 1. The f of 2 ends up being 1, which I end up plugging in there. So that would be 8 and 11. Moving on, find the inverse. All right, and if I'm moving too fast through these, take a time, pause, go back, look at it again, because that's the beauty of having it on video. You can always rewind, you can always look at it again. So finding an inverse is a process by which you first switch x and y. And I'll show you what that looks like in a second if you don't remember that. It's not that difficult. And then second, you solve for y. Okay, so you switch x and y, and then the second thing I do is solve for y. Well, first you're like, well, where's y? F of x is essentially the same thing as y. So first thing I'm going to do is rewrite this as f of x being y. At this point is your inverse step, where I'm going to take y and x and flip them. So if you just watch this, all I did was just replace x with y and y with x. So at this point, I'm stuck solving for y. So I'm going to change markers and just do the rest of this problem, because the rest of this is just algebra. So I multiply both sides by 9. I get 9x equals 3y plus 5. I'm going to subtract 5. I get 9x minus 5 equals 3y. All right, get y by itself, divide by 3. So y ends up equaling 9x minus 5 divided by 3. So you're looking at that, and you're like, well, it asked me for the inverse. It didn't ask me for y. So the proper notation for this is f negative 1x. It's the inverse. So f negative 1x is equal to this value that I found down here. So that's 9x minus 5 over 3. All right, and just real quick note, verifying if you guys did the problems right before this problem on your review. Verifying is to say, if I take f of f inverse, that should equal x, and f inverse of f should equal x. And if you're not sure what that means, ask your teacher. But essentially, you're going to take a function, you're going to take the inverse and plug it in. So you're going to take this function and plug it in for x here. You should get x. And then you'll take this function and plug it in for x here, and you should get x. But that's for the problem before. The answer to this question is the one in the box at the top. Okay. Moving on, factoring completely. This problem is a sum of cubes. So just to kind of refresh your memory of difference in sum of cubes, it's just a form. It's something that you just need to remember. So it's u plus v, u squared minus uv plus v squared. If it's u cubed minus v cubed, it's u minus v of u squared plus uv plus v squared. So this is what I end up with. Those are my two forms. So the first thing I have to do, I'm looking at this problem and I'm like, yeah, that's the difference for sum of cubes. First thing I have to do is to rewrite these two things as cubes. So the first thing I say is, well, what to the third makes 64? And you say for a second, you're like, okay, I'll do 2 to the third, 3 to the third, 4 to the third makes 64. If you didn't know that, use your calculator to figure it out. The next thing is what to the third makes x to the third. That's easy, x, right? What to the third makes 27? Well, that's 3. And then what to the third makes y to the third is y. So now this is u and this is v, and I just follow the form. So from here on out, it's just a matter of following things one step at a time. So u and v go in the first parentheses. I'm going to take u squared minus, again, these signs are opposites, minus u times v. And I'm going to say plus v squared. Okay, so I did just follow the form, but again, it started with this step here. Okay, some little things to remember. If you don't have this in your calculator, you don't remember. Just little things, like this sign is always the same as the sign in the first parenthesis. And if you notice, those two signs that I'm highlighting there, I'll highlight them in a different color, but these two signs in yellow right up here, those are always opposites. So the first sign here tells you what the first parenthesis sign is going to be, and then you know that the second term in the second set of parentheses is always opposite. But just a little side note. And now let's finish this question by multiplying this all out. So 4x squared is 16x squared. Don't forget to square the 4. Negative 4x times 3y is negative 12xy, and then plus 9y squared. So this is my final answer to the difference of sum of cubes problem there. Okay, moving along. Find the real number solutions. Real number solutions, basically they're based on the degree. The degree of this problem tells us, the degree being 3, tells us there should probably, again, not always, probably be 3 solutions. Okay, so you're thinking like degree 3, 3 solutions. So this particular problem, I think it only ends up having 2, but it should probably be 3. But again, if it only has 2, you'll see why it only has 2 in a second. So I look at that and I'm saying, okay, can I do MAF? No, not really. There's not a constant. Can I do difference of cubes? Not really. Like this thing's not a perfect cube. The only thing you can do, and actually get you the answer pretty quick, is take out a greatest common factor. The GCF out of these two is x squared. Okay, when I take a GCF out, just to show you what I did, you divide each of these by that GCF. All right, you pull it out front. X to the third divided by x squared is x. Negative 4x squared divided by x squared is negative 4. So now my zero products property says either x squared equals 0 or x minus 4 equals 0. So now at this point I square root. And you see right here, This is where I lost one of my solutions because the square root of 0 is 0, plus or minus 0. It doesn't matter. It's just 0. So I should have had 2 because typically when you square root a number, you get 2 solutions. Square root of 9 is plus or minus 3. Square root of 4 is plus or minus 2. Square root of 0 is plus or minus 0, which gives me 1 solution. So I should have got 2 right there, but only got 1, which is why I should get 3, but I only get 2. So I add 4 both sides here. X ends up being 4. So your 2 solutions here are 0 and 4. Once again, 0 is basically like a double solution for this particular question. All right, moving on. Given the polynomial function f and 1 0 of f, find the other zeros using synthetic division. For this problem, I'm going to go to my calculator. And for the purposes of this, I'm going to type it in. Because I'm looking at this and I'm like, I got an x to the 4th. And if I do synthetic one time, I'm not going to be able to get the rest of the solutions because I will only be it would only be down to x to the 3rd. And I'm not too sure exactly how to solve that. I'm a math teacher, so you got to have 2 zeros. You got to get it down to x squared so that you can do MAF. So first thing I'm going to do is type it in. So x to the 4th plus 2x to the 3rd minus 13x squared minus 38x minus 24. And now I don't care so much about the graph as I do about the table. So I'm going to second graph, I'm going to look at my table. My table's all messed up, so I'm going to go to table set, which is second window. I'm going to start the table at 0, and I'm going to delta table 1. Again, if this is going too fast, just slow it down. Pause it, rewind, look at it, look at what I did again. So now I'm going to look at my table, and I'm going to see what's going on. So I see that I got another 0 at 4, if you can see that. And I got 3 other zeros at -3, -2, and 1. They told me the one at -3. Okay? I'm also going to take the one that I saw first at 4. I know that you saw all 4 zeros. All right, it might be tempting. And if this is a multiple choice test, yeah, go to your calculator, find the 4 zeros. But if this is a written test, your teacher, me, or your other teacher is going to want to see the synthetic division. So I'm going to use both zeros. So let's see what that looks like. So synthetic division is just a process. This polynomial is not missing any terms. It goes x to the 4th, x to the 3rd, x to the 2nd, x, and then my constant. So I'm going to go 1, 2, -13, -38, -24. And I'm going to do synthetic. So synthetic, again, just real quick recap. You bring your first term down, you multiply. 1 times -3, you add straight down. You multiply with 3, and you add straight down. You multiply, and you add straight down. And what should happen is that your remainder should be 0. Okay, your remainder doesn't really matter. It's not part of the problem in these problems. It is part of the problem. I don't want you to think it doesn't matter at all. But for the purposes of my next thing, that's just my remainder. So then this is my constant, this is my x, this is my x squared, this is my x to the 3rd. I'm not done, because if I just ended with x to the 3rd, I wouldn't be able to solve it. So now I'm going to do synthetic again with the other 0 that I found 4. So once again, I'll bring it down. I get 1, multiply, add, multiply, add, multiply, gives you 8, add, again, remainder 0, checks out. So now I'm left with these 3 numbers, okay? So this is my remainder. And it goes backwards. This is my constant. This is my x term. This is my x squared. If there was another one, again, I work right to left with that. So then this is 1x squared plus 3x plus 2. And I want to find the other 2 zeros. Like I said, we already saw them in the table. So when I do this, I'm going to see them again. But I just want you to see the steps involved in case you don't have it. So what multiplies to 2 adds to 3. That's 1 and 2. So it's x plus 1, x plus 2. So x equals -1 and -2. So put it all together. My zeros, I got -3, which was given to me. I got 4, which I found from my calculator. I got -1 and -2, which I saw on my calculator, but I actually found them, solved these. So I used synthetic and MAF. Okay? But again, I did see those in my calculator, so that's another way to check that you did it right. But I want to see the steps that you use to do that. All right, moving along. Write a polynomial function that has the given zeros. All right, so I see 6 and 3i. And what's weird about I, if you don't remember, I equals the square root of -1. So that means I always comes with a pair. For that reason, you can't get I without also getting -I. If I is a solution, -I is a solution. So for this problem, if 3i is a solution, then -3i is a solution. All right, and here's where I told my students, if you got plus or minus 3i as solutions, basically what you did at some point was you took the square root of -9. If you're like, what are you talking about? Well, the square root of -9 equals I root 9, which equals plus or minus 3i, which is basically how you would get 3i and -3i. If you don't see that, you can always just think about these things as being zeros, and then I would write the factors. Okay, so if these are zeros, then my factors could be x minus 6, x minus 3i, and x plus 3i. Okay, you'll see in a second though, like if you could just take this and just know that's going to be x squared plus 9, that's fine too. Okay, so but we'll do through this because it'll tell you the other little tricks about I. I'm going to leave x minus 6 alone for a second. I'm going to FOIL x minus 3i and x plus 3i. So when I do that, I get x squared plus 3ix minus 3ix. Those are going to cancel. And then my last, I get negative 9i squared. Okay, so once again, these go away. I get x squared. Negative 9i squared. I squared is what? What is the other rule? I squared equals what? Yes, everybody, -1, right? So that's going to be negative 9 times I squared, which is -1. So just showing every single step so I'm not skipping anything. I squared equals -1. So now you can FOIL this and get your polynomial. So I get x to the third. Outer is going to be plus 9x, inner negative 6x squared, and then last minus 54. So I'm going to rearrange it. So my function y equals, or f of x equals x to the third minus 6x squared plus 9x minus 54. And when we originally did this, I said once you see this, you can almost jump right to this point, okay? Because you know if 3i and -3i are zeros, the only way that happens is if you set x squared plus 9 equal to 0, because that will give you x squared equals -9, and that would give me x equals plus or minus 3i. If you can't jump to that, I mean, you can't jump to the highlighted parts, that's okay. Go through all the steps. But if you go from here right to this step, that's fine. And that's actually probably the easiest way to go. All right. Next question. Give exact answers. So this is a calculator question. These are your log problems. For the purpose for number 45, you want to get that 4 to the x by itself. Again, logs give us a way, just to remember, logs give us a way to solve problems with variables in the exponents. So for number 45, I'm going to subtract 5. So I got 3 times 4 to the x. 773 minus 5 was 768. Divide by 3. The whole goal here is to get the x by itself. So 768 divided by 3. Yep. So 768 divided by 3 gives me 256. And if you think of that, like, I could probably figure it out by hand. Yeah, you can. I think 4 to some power equals 256. But let's do the log. So there's two ways. There's two schools of thought. Your teacher might have taught you to change this to an exponent. Okay, that's fine. If you change the exponent to a log. So if you change this to a log, then it becomes log base 4 of 256 equals x. And then in order to solve that, you do ln of 256 over the ln of 4, and you get your value for x there, which the ln of 256 divided by ln of 4 is 4. All right, so cool, there's an answer. The other way you could do it, which is the way that I taught my students, is you see, like, it's just an operation you want to do to both sides. So I would take the ln of both sides. Okay, when I do that, I take ln of 4 to the x equals ln of 256. This x, by the power property of exponents, comes out front. So it's the ln of, or x ln 4 equals ln 256 divided by ln of 4. And what you notice is x equals 256 divided by ln of 4, which is 4 either way. So no matter how you do it, you should get x to be 4. All right, so again, some teachers might teach change to a log. Some teachers might teach ln both sides. Either way you do it, you would get x is 4. But the whole trick is to get 4 to the x by itself to begin. All right. For number 46, once again, you want to get your log base 6 of x minus 4 all by itself. So in order to do that, I got to divide by 18. I get log base 6 of x minus 4 equals 2. Okay, the only way I think teachers teach to solve this is to change your log back to an exponent. Okay? Okay, so how you do that is you see like you got base 6 to the second equals x minus 4. So 6 to the second is 36 plus 4. I'm going to add the 4. You get x is 40. All right. So once again, this was probably one of the trickier of the tests you've taken. But again, if you want to find the variable in the power, you ln both sides. That's how I teach it. You also could change it to a log. If you got a log and you want to change it back to an exponent, that's the way you want to solve that. All right. Moving along. The properties of logs to expand the expression. Okay, so just real quick recap. There are 3 properties. Okay, you got your quotient property, you got your product property, and you got your power property. Okay, so the quotient property says this: if you got a log of 2 things divided, you can break those up by splitting up the log with a minus between them. If you got a product of 2 things within a log multiplied, you could break those up by adding. All right, and then the power property says something that we just used in the last problem. But if you got a power in the problem, then you could pull that power out in front. All right, so those are your 3 properties. Real quick recap. You might have been able to find those in your notes, but if not, there they are. So in this particular case, you got a quotient. So I'm gonna go in the order that I just wrote those. I'm gonna see the quotients. I'm gonna take care of the products. I'm gonna take care of the powers. So the first thing is I take care of the quotients. So I would split up to 2 things that are divided by subtracting. Okay. Now I look at, and again, all I'm looking at here are these parts. So now I'm going to look at these 2 parts, and I still ask myself, do I have any more quotients? The answer is no. Do I have some products? The answer to that is yes. I got a product in the first one, and in the second one I have nothing, so I'm just going to rewrite it. Now I look at these 3 pieces, and I ask myself, do I have any products? Do I have any quotients? The answer to both those questions is no, but I do have some powers. The powers come out front. So the final answer to this question is 3 log base 7 of x plus 2 log base 7 of y minus 3 log base 7 of z. And that would be the full expanded version of log base 7 of x cubed plus y, or x cubed times y squared divided by z to the 3rd. All right, the other direction asks you to condense. So, but yeah, so when you condense, you would take this log here, this 3 logs, and you would go backwards in that same way. So you'd start with your power properties, go to the product, and end with the quotient. So you would go backwards, ending with 1 log if that problem asks you to condense. Okay.